All right, in 108, you should have learned some basic derivative rules and some derivatives of some basic functions. All right, you would have learned that the derivative of a constant times a function is equal to the constant times the derivative of the function. Okay, derivative of the sum of two functions is the sum of the derivatives. Derivative of a difference is the difference of the derivatives. Okay, so those are pretty straightforward. Now, notice we don't know anything. We know about sums and differences and a constant multiple of a function, but we don't know anything yet about what happens when you multiply functions. What happens if you have the quotient of functions? So we're going to get to that in soon, yeah, probably in another day. But this is all we know for right now. You would have also learned the power rule, right? This is often called the power rule because you're taking the derivative of a power function, right? So this is the power rule. All right. And I don't know if they went into why that is or they just gave it to you. But it's just a good one to know. You just need to know this like the back of your hand. You also know the derivative of a constant, right? So if you take the derivative of a constant, now you can kind of visualize what a constant looks like. If you have a y equals some constant function, that's just a flat line, right? So it would make sense that the slope is 0. You can also think of that derivative of a constant as just being a special case of the power rule as well. If k is the same as k times x to the 0 because x to the 0 is just 1. And if you drop the exponent, which is 0, you're multiplying by 0. So you'll get 0 that way too if you just treat it as a special case of the power rule. You should have also learned the derivative of exponential functions, particularly e to the x, e to some power functions. All right, so the derivative of e to the kx is equal to k e to the kx. Now, you may or may not have learned these last two. Since we've got the derivative of an exponential function in terms of a base e, it doesn't hurt you to have a derivative of some other base. In this case, that I'm calling the base a. Okay. So, and also, now this one I'm not sure because you didn't cover natural logs in 108. But I'll just give it to you. The derivative of the natural log is 1 over x. Okay, so these are derivatives of basic functions that you should just have memorized. You need to know these. If you want more explanation of where these come from, I can give you that. Just let me know. But these are ones that you need to know. All right. So let's practice using them. That's what example 2 is. It's just a bunch of practice. And that's what we're going to do in class. It's a bunch of practice. It just takes a lot of practice to get all these basic rules down. So so the first part of example 2 is we want to find the derivative of 14x squared. All right. So actually, I might want to keep these rules up here for now anyway. So we're just going to use the power function, and we've also got a constant multiple of a power function, right? So we're going to have the 14, right, times the derivative of x squared, which is going to be 2x, right? I'm just bringing the n is equal to 2. I'm bringing that out front and then decreasing the exponent by 1. And then I have a constant. Now this is a sum of two functions effectively, and the second part of the sum is just a constant, so that's just going to be 0. Okay, so what I end up with is 28x. That's my derivative for this. I guess I could call that part A. It's, for number 1 in example 2. All right, how about the next one? This one's a little tricky. You have to rewrite it to make it work out. Because if you look at the basic functions that we know derivatives of, this doesn't look like any of those. But we can use our properties of exponents. We're just going to divide everything by x cubed, right? So if I divide 5x by x cubed, I get 5x to the minus 2. If I divide 2 by x cubed, I can rewrite that as 2x to the minus 3. Okay, so now you can see that it's the sum of two functions. Those functions have constant multiples, and I can see that they're just power functions, right? So I have a constant multiple of x to the minus 2 plus a constant multiple of x to the minus 3. All right, so now let's figure out what the derivative of that is. All right, so we're just going to basically, we got 5 times the exponent, which is going to be minus 2, so that makes it minus 10. And then we need to decrease the exponent by 1, which gives us minus 3. And then we're just going to add the derivative of this next thing. So I have 2 constant multiple of that, but then when I use the power rule on x to the minus 3, I'm going to get that 2 times the minus 3, which gives me minus 6. And then I have to decrease the exponent by 1, so that becomes minus 4. Okay. So I can just leave it that way. In fact, I would recommend just leaving it that way. You can also write it as minus 10 over x cubed, minus 6 over x to the fourth if you'd like to. But in general, with these derivatives, I would bother simplifying them unless there's a reason to. Okay. All right, so I would recommend, this is another one where I'm going to go through all of these, but I would recommend that you pause the video and try some of these yourself. And I'll just keep going through them, pause at any time. All right, so let's look at this third one. I'm going to rewrite this as a power function. This is x to the 1/2, right? So now if I want to find the derivative, I just apply the power rule. So it becomes 1/2 x to the 1/2 minus 1, which is minus 1/2. Okay, now I can rewrite that if I want to. I don't need to because it's just 1 over 2 square root of x. All right, let's look at the next one. So I have a constant multiple of an exponential function, and I'm gonna rewrite the 1 over x as a power function. So I have 4e to the x minus x to the minus 1. This makes it a little more straightforward as far as applying the power function or power rule. I mean, all right. So h prime of x is equal to, I have a constant multiple of the derivative of e to the x. Derivative of e to the x is just e to the x. Okay. So in this, I know that in the rule it stays kx, but in this case k is just 1. So derivative of e to the x is e to the x. All right, and now we got to apply the power rule on the second part. So we have a negative, and then we're going to bring the exponent out front. So it's negative times negative 1, so that becomes a positive. And then we're going to decrease the exponent by 1, so it becomes minus 2. Okay. And I would just leave it that way. All right, let's take a look at the next one. We have p of x equals 50 e to the 2x. So we have a constant multiple of a exponential function. So we're going to have 50 times the derivative of e to the 2x, which is going to be 2e to the 2x. Okay. Now I can rewrite that as 100 e to the 2x. Okay. I mean, as you get better and better at this, you'll go straight to just writing 100 e to the 2x. In fact, you may already be there. All right, let's take a look at this next one. All right, so this is one where it's an exponential function, right? It's an exponential because the variable is in the exponent. In this case, we're in the form of this a to the x, right? We have an a to the x, where a in this case is 1.05. Okay, so we have to apply the basic derivative. And so we're going to have 250 because that's just a common multiple. And then we have to have the natural log of 1.05. And then times a to the t, which in this case is 1.05 to the t. Okay, and then we have to take the derivative of the second part. We have a difference, but in this case it's just a constant, so it's just going to be 0. So I'm just going to leave it off. All right, we got a couple more here. All right, this next one's a little tricky. We have y equals e to the 2x plus 1 plus 3 natural log of x. Okay, well, I don't know about I know e to the x or e to the 2x, but not e to the 2x plus 1. But I'm going to use the properties of exponents to rewrite this, because I can rewrite this as e to the 1 times e to the 2x, right? That's the same as e to the 2x plus 1. That way I just have a constant multiple of e to the 2x, and I know how to take the derivative of e to the 2x. And the rest is, I'm just going to leave it as it is. It's just a constant multiple of the natural log function, and I know how to take the derivative of the natural log. So what do we get? We're going to take, this is just a constant, right? And then the derivative of e to the 2x is 2, I'll put a little dot there, e to the 2x. And then we have a constant multiple of the derivative of natural log, which is just 3 times 1 over x. So I'm just going to write it as 3 over x. Okay. Now I could leave it that way, but I could also go back and I could combine those two e values here, because e to the 1 times e to the 2x, just like I did before. I still have this 2 here. I'm going to get e to the 2x plus 1. And then I'll just leave this as it is. All right, one more here. Now I have a hint on this one. It says use the properties of logarithms. I know how to take the derivative of natural log of x or natural log of t, but not the natural log of 2t. Okay, not yet. So what I'm going to do is use the properties of exponents. I'm going to break this up into the natural log of 2 plus the natural log of t, right? That's the product property of logarithms. And now that natural log of 2 is just a constant, right? So I just have the derivative of the natural log of t, right? Because this constant, when I take the derivative of it, just becomes 0. So just realizing back here I should have written y prime or dy dx because this was just a rewrite. Okay, so I'm going to write g prime of t. Okay, take the derivative of the constant and get 0, so this just becomes 1 over t, because the derivative of the natural log of t is just 1 over t. All right, I guess that's all the examples I'm going to go through. And I go ahead. There's quite a few practice problems in the discussion questions. I would recommend maybe taking a look at those and doing some of them ahead of time, just so that we can get through everything we need to in class, and then you can compare answers with your classmates. So I'll let you do that, and I will see you in class.